afternoon, grade 11s, and welcome to our first Telematics broadcast for mathematics for grade 11s. And welcome to all the schools that are logged in and our new pilot schools as well. My name is Eleanor Splinter, and I hope that you are going to enjoy this mathematics session with me. We sent the paper through to all the schools, and I chose the questions because obviously we only have less than an hour to get through the paper. So I'm going to be doing mathematics paper 1 today, and then my colleague Mr. Tregoning will be doing paper 2 in a few days' time. So I've chosen questions 4, 5, 6. Anytime grade 11s, just quickly, if you do have a question, please feel free to SMS your question through to me. You can also WhatsApp it through, and I will be more than happy to look at your question and see how can I assist. Just quickly, for the people who are tuned in for the first time, you have your books, you have your exam paper next to you, and you're working with me. Remember, telematics is an interactive session. So you're sitting and you're working with me, and if you have the answer before I even have it, please feel free to just send it through to me and I can tell you if you are correct. So grade 11s, let's start with our first question. So I have question number 4. Remember, there's question 1, 2 and 3 obviously, but because of time constraints we can't do the whole paper, so I've chosen to start with question 4 first. And question 4 says that this is a quadratic number pattern. So I have 3, 5, 8 and 12. Now grade 11, they tell you that it's a quadratic pattern. Now if someone tells me that this is a quadratic pattern, then I have something to tell them. What is it that I want to tell them? I'm going to tell them that the second differences are the same. Let's see, from 3 to 5, I have to add 2. From 5 to 8, I have to add 3. And from 8 to 12 is 4. 12 minus 8 is 4. 8 minus 5 is 3. 5 minus 3 is 2. So what you can see, this is not a linear pattern. Why is this not a linear pattern? Because your first differences are not the same. You go into your second differences. 3 minus 2 is 1. And 4 minus 3 is 1 as well. So these are your first differences, and this will be your second differences. Now what do you notice? You notice that your second differences are the same. They both 1. Hence, it should be a quadratic pattern. But what is the question? The question is that I have to determine the value of term 26. So what I'm going to do, grade 11s, I'm first going to find my Tn formula. Now my Tn formula is an squared plus bn plus c. Remember that you do not get a formula sheet in an exam or a test, so you need to know these formulas out of your head. Please, grade 11s, study them. So why am I writing Tn is an squared plus bn plus c down? Because it's a quadratic pattern. I now need to find the value of a, the value of b, and the value of c. If you know what it is already, you can tell me and send your answers through. How do I find the a? I'm going to use the formulas here that says 2a is equal to 1. And hence, I can find my a. My a is equal to a half. So now I'm going to find the value of b, and I use the formula 3a plus b is equal to 2. You take the first numbers in every row. So 2a is equal to 1, a is equal to a half. Then we use the formula 3a plus b is equal to 2. But I have a. I know what the value of a is. The value of a is a half, so I'm merely going to substitute the half into the place of a, and then I can find b. Now remember, 3 times a half is 1.5, and if I take it over to the other side, 2 minus 1.5 gives me a half. The only variable that you must still go and find is C, and we use the formula A plus B plus C is equal to 3. Now grade 11s, these formulas do not change ever. So you always say 2A is equal to your second difference. 3A plus B is equal to the first value in your first row, in the second row, and A plus B plus C is the first value there of the pattern that was given. So I am going to use A plus B plus C is equal to what? Is equal to 3. I have the value of A already, it is a half. I have the value of B already, it is a half as well. And now I can find the value of C. A half plus a half gives me 1. Take it over to the other side, 3 minus 1 gives me 2. Can you believe it? There you have your TN formula. A is a half n squared, B is a half n, and C is equal to 2. But that wasn't the question. The question wasn't to go and find the TN formula. The question was to determine term 26. But if I have the TN formula, I am merely going to substitute the 26 in the place of n. As easy as that. So I'm going to say term 26 is equal to a half. Substitute 26 into the place of n. Substitute 26 into the place of n plus 2. If you put this on your calculator, you are going to find that term 26 is 353. What do you think about this sum, grade 11s? Not difficult at all. But what do you notice? There are 4 formulas that you needed to remember. First formula is your TN formula, AN squared plus BN plus C. And then these 3 formulas here. 2A is equal to 1. 3A plus B is equal to 2. And A plus B plus C is equal to 3. Remember, it's the first numbers in every row, and you need to remember these formulas. They can't be anything else. It stays the same. No changes, and it works for every quadratic pattern. Now, that is quite an easy question, I would say. And we would put that at a level 1 question. So level 1 is you all supposed to get it right. All right. So you can't struggle with something like that. The only students who will struggle with a question like that are the students who didn't study the formulas. It's a basic, simple using of formulas. But then I come to question number 4.2, which obviously you also got in your question paper. And this I would put on a slightly higher level. Little bit of more work, more thinking involved, but yet I'm still using my basic knowledge. Are you ready to go to this question? It says a certain quadratic pattern. I stop immediately. A quadratic pattern? What do I tell them? Oh, wait. A quadratic pattern means the second differences are the same. If this question said that it was a linear pattern, the first differences would be the same. So you've got a bit of information from this. A certain quadratic pattern has the following characteristics. A quadratic pattern tells me that the second differences are the same. Okay. Now look at this information that they gave you. They gave you 4 bits of information. I tried to put them in bullets so that you can see. And it says that term 1 is P. So I'm going to say term 1 and I'm going to put my P here. Term 2 is the value of the second term is 18. All that I'm doing, grade 11s, is I'm taking what is given to me and I'm putting it down as my information. Welcome to New Orleans also, guys. It's always nice to see that you logged in and that you are so passionate about logging in and that you want to work even if it's after school because you want to do well. Remember, these marks, the November marks, go into the universities and the technicons, obviously, and you can see those marks, these marks are very, very important. So I am encouraging you to never stop working hard. Term 1 is P, term 2 is 18. Now look at this quickly. They tell me that term 4 is 4 times term 1. So I don't know what term 3 is yet. There's no information about term 3, but they're telling me that term 4 is 4 times term 1. Now term 1 is P. So term 4 will be 4P. Does that make sense? 4 times term 1. Now can we check what information they tell me about term 3 minus term 2? They say that term 3 minus term 2 is equal to 10. Term 3 minus term 2 is equal to 10. So the difference between term 3 and term 2 must be 10. Do you agree with me that term 3 should then be equal to 28? That's not difficult to see. Hey, what is the difference between 28 and 18? Term 3 and term 2 gives me 10. And now grade 11s, the question says that I must determine the value of P. Now listen very carefully. If you want to go ahead and try the sum and then SMS and tell me what your answers are, that would be absolutely fantastic. That's how you learn mathematics. Not just watching how somebody does the sum, but actually trying it yourself. So I am going to now start. This is my information. Just check if you agree with me. Term 1 is P, term 2 is 18. The difference between term 3 and term 2 is 10. I can see that clearly there. And term 4 is 4 times term 1. I am now going to work out the first differences. The first difference here is 18 minus P, because it's term 2 minus term 1. Never term 1 minus term 2. That you know. 28 minus 18 gives me 10, because that is what it told me. The difference between term 3 and term 2 is 10. And the difference here is going to be 4P minus 28. Are you quite happy with that? Now grade 11s. I cannot use these first differences now already to solve for P, because it is a quadratic pattern, so your second differences are the same. So these are my first differences. I'm going to write it here for you. These are my first differences. Now I'm ready to go and work out my second differences. So the second difference here will be 10 minus 18 minus P. Remember, put this 18 minus P in a bracket because it's two terms. So it's term 2 minus term 1. Now I have 10 minus that. Now I'm going to say it's 4P minus 28 minus 10. Now I work this out. This is 10 minus 18, which gives me minus 8. And negative times a negative is a positive, which means that gives me negative 8 plus P. Here I can go 4P minus 28 minus 10 is negative 38. And there you have the second differences. So grade 11, this is a second difference and this is a second difference. Now what right do you have? You have the right to put this second difference, which is negative 8 plus P, equal to that second difference, 4P minus 38. But what gave you this right? Why do you have the right to equate negative 8 plus P and 4P minus 38? Why? Because they told you that it's a quadratic pattern. So if it's a quadratic pattern, the second differences are equal. The only thing in this second difference, grade 11, is that you have a P, but you put them equal to each other, and now, without even struggling, you solve for P. I'm going to take this P across, so it's 4P minus that P gives me 3P. Negative 38 plus 38 is equal to 30. And then you're going to say P, 30 divided by 3 is 10. And there you have the answer. And you know what? We said P is 10, right? So you can quickly just check your answer. If P is 10, then that value there is 10. That is 18. That is 28. This is 4P, so it's 4 times 10, which gives you 40. What's the difference there? 8. What's the difference there? 10. What's the difference there? 12. And there you can see your sum must be correct because your second difference is equal to each other. Grade 11, after this, obviously your teachers can ask you to determine the value or the formula for Tn, but then we know Tn is an squared plus bn plus c. Just see if you remember the formulas with me. Here you're going to say 2a equal to 2, 3a plus b equal to 8, and a plus b plus c is equal to 10. I hope that you understood those two quadratic number patterns that I did with you, because the quadratic patterns are the most popular in paper 1. They do ask a linear pattern, but the quadratic patterns are more popular in grade 11 and they count the most marks. Then grade 11, like I said at the beginning of the session, because we want to get through as many questions as possible, I will be going slightly faster than I usually go, because I want you to go through it, all of it with me. But don't worry, you can always have a look at the or on YouTube or whatever, so that we can get through as many questions as possible. I am now going to go into question 5, which is the graphs. Question 6 is a graph question, and question 7 is a graph question. Why did I choose this? Because we're battling with graphs. So we're battling with graphs in this paper, and then the other section, number patterns, and then also a little bit of probability. But let's see if we can go through the graphs, all of them this afternoon. Do you know what? Graphs counts the most in paper 1. Okay, so I have this information here with me. I'll put the question there. All I want to see if you can get a very clear picture of the graph. It says the sketch below shows the graph of -9. Now I'm going to write this immediately. It shows, and I've also retyped it here so that it's clear for you. It says the graph below shows the graph of f of x, which is -9 over x minus 1 minus 2. And this is the graph here. They say that A is the point of intersection of the asymptotes of f. I hope that by now you can all see that this is a hyperbola. Okay, and this is the hyperbolus equation. -9 x minus 1 minus 2. Now if I look at this equation of the hyperbola, I already know that this is my x asymptote, and the -2 is my y asymptote. So if I say y asymptote, it means it cuts the y-axis, and if I say x asymptote, it means it cuts the x-axis. Is that clear? Now, A is the point of intersection of the asymptotes, and this is the information that I have, and all of these questions, I've retyped it so that we can just see it clear. The first question says, write down the coordinates of A. Now, A is here. Can everybody see? Now, A is the intersection of your asymptotes. So if I write down the coordinates of A, I'm going to say that A is 1 and y is -2. Not a difficult question. Just quickly, grade 11s. An asymptote here means what can't x be? X can't be 1. Because if x is 1, 1 minus 1 is 0. And you're not allowed to divide by 0. And that is why your x asymptote is always the opposite of this -1. So many people say, ma'am, my x asymptote is -1. No, grade 11s, it's the opposite. If it's -1 here, your asymptote will be +1. If it was +1, your asymptote will be -1. The y asymptote, no sign change, it is just -2. So write down the coordinates of A, it is 1 and -2. That was question 5.1.1. You guys are still okay. Then the next question says, determine the coordinates of the x and y intercepts of this graph. Now listen very carefully. This question is quite popular. If you are asked to determine the y-intercept of any graph, you merely make x 0 in your equation. If you are asked to determine the x-intercept, you merely make y 0. Do you understand? So if I have to determine the coordinates of the x and y intercept, what I am going to do is I'm going to take my equation. Remember, this is f of x here, but f of x is y. It's -9 over x minus 1 minus 2. I am first going to determine the y-intercept. So if I'm going to get the y-intercept, what must I make 0? I make x 0. So x becomes 0. All the other numbers remains the same. Can you see that you are now able to find the y-intercept? Negative 9 over negative 1 gives you 9, and 9 minus 2 is 7. So the y-intercept would be x is 0 and y is 7. If I go to my graph, it is definitely this point here. You see, because it cuts the y-intercept. So I'm going to write here that it cuts the y-axis, that point is 0 and 7. So I've just determined the y-intercept, but now I'm going to get the x-intercept. I'm still using grade 11, this equation that was given to me. If you want to determine the x-intercept, you now need to make y naught. So you are going to say 0 is equal to negative 9 over x minus 1 minus 2. And you are going to get x alone. I'm first going to carry this negative 2 over to this side, and it gives me 2, which is equal to negative 9 over x minus 1. You can either say you're going to cross multiply here, or you're going to just multiply each fraction by x minus 1, as x minus 1 is your LCD. So I'm going to say 2 multiplied by x minus 1 is equal to negative 9, because x minus 1 is the LCD. Take your 2 into your bracket. It's 2 times x is 2x, minus 2 is equal to negative 9. 2x, negative 9 plus 2 gives me 7, negative 7, and x is equal to negative 7 over 2, or negative 3 and a half. And so my x-intercept would be negative 3 and a half, and y is 0. Now look on your sketch quickly. Can you see that that point there represents the x-intercept? And that x-intercept is negative 3 and a half and 0. I hope that that was quite good, and that you knew exactly what to do if you were asked to determine the x and y intercept, and then also from your equation to identify your asymptotes. This is the y asymptote because it cuts the y-axis, and this is the x asymptote because it cuts the x-axis. Remember, this point here we said will then be equal to, what is the x value? It's 1. And what is the y value? Minus 2. And remember not to say negative 1, because if you put negative 1 into the place of x, this fraction is defined. What does an asymptote mean? What can't x be? X can't be 1. 1 minus 1 is 0. Okay, grade 11s, that's already question number 5.2. I hope that I'm not going too fast and that you are understanding the work. The next question has become so popular in the papers. It seemed to be asked all the time. Every question paper now I see axis of symmetry of a hyperbola. Okay, so first of all, it says write down the equation of the axis of symmetry of f that has a negative gradient. All right, so that's quite a mouthful, so I'm going to try and break it up into little pieces for you. What does an axis of symmetry do? An axis of symmetry is a line for the graph that cuts the graph in half. So if I fold my graph on the axis of symmetry, the one part will fall on the other part. This is my axis of symmetry. The line going down here, this half is equal to this half here. So in a hyperbola grade 11s, you always have two axes of symmetries. The one axis of symmetry will have a positive gradient, and the other axis of symmetry will have a negative gradient. I'm going to draw it in for you, and then we're going to get the equation. This one that they asked me said, write down the equation of the axis of symmetry with the negative gradient, but I also want to do the positive gradient with you. Let's first just see what the axis of symmetry look like. So I have my ruler here, and the axis of symmetry will always pass through where your asymptotes meet. So this will be my one axis of symmetry, right? But I have another axis of symmetry, and it's going to be this one here. So you have two axes of symmetries, and I promise you, grade 11, you can fold this graph on here. This part will fall on this. You can fold this graph, they will fall on top of each other. And so these are the axes of symmetry. Now this axis of symmetry has a positive gradient. Remember, all that happens is this line here would have been your axis of symmetry had you not to have that asymptote and had you not to have that asymptote and that asymptote there. But all that what happened was this axis moved 1 unit to the right and your y dropped by 2 units. So now your axis of symmetry would be passing through the points where your asymptotes meet. So this axis of symmetry here will be y equal to, it's a positive gradient, x, but you don't know what c is. Why? Because your axis shifted. This one shifted 1 unit to the right, and the y shifted 2 units down. So this is your positive axis of symmetry. This one here has a negative gradient, so it's negative x plus c. So grade 11s, if ever you are asked to determine the axis of symmetry for a hyperbola, it's never anything else but this. Y equal to negative 1x plus c and y equal to x plus c. Now remember, in our question they ask for the negative gradient, so I'm going to be using this one. So when I work this out, all I'm going to say is y is equal to negative x plus c. You don't know what c is, so you are going to substitute a point on this axis of symmetry, and the only point that you have is 1 and minus 2. So the point that you substitute will always be the point where the two axes of symmetry, where the two asymptotes meet. So x is 1 and y is minus 2. So you substitute minus 2 in the place of y, and you substitute 1 into the place of x. Hence, making c equal to, take the minus 1 across, becomes plus 1, minus 1. So the axis of symmetry is negative x minus 1. Was that quite easy? If the question in your paper is the positive axis of symmetry, you write exactly the same equation down but with a positive gradient, and you still substitute the point of intersection of the two asymptotes. X is 1 and y is minus 2. Y is minus 2, x is 1, making c equal to negative 3. So that is your positive axis of symmetry. So this is the one with a negative gradient, and this axis of symmetry is the one with a positive gradient. In our case, they asked for the negative gradient, so you will only give this answer. But if they want both, you write both down. Normally, they just ask for one. Never ever does this change. This is always the equation for the hyperbola's axis of symmetry. Okay, so we're doing quite well. I hope you're still understanding. And we are now going to go to question number 5.1.4. This is question number 4 on this hyperbola. We've done quite a lot. We know what the axis of symmetry is. We know how to get our asymptotes. We know how to get the x and the y intercept. I found the following question to be quite an interesting question, and I thought we must do it. And it's a 5-mark question if you look in your paper, and it says, hence or otherwise determine the coordinates of a point that lies on F. So this point has to lie on our graph that lies on F in the 4th quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant number 4. So this point has to lie on F. It has to be in the 4th quadrant, which is the closest to point A. So what point here on F will be the closest to point A? and that is the point of intersection. The closest point to A is the point, I want you to write this down, the closest point to A is the point of intersection between your hyperbola, between F and, what do you say? The line for the axis of symmetry. And the axis of symmetry. I'm going to write here and. So I wrote the closest point to A is the point of intersection between F and the axis of symmetry. You want it in the fourth quadrant, so we are going to use obviously this axis of symmetry here. So point of intersection, grade 11s, I take my one graph and I put it equal to the other graph. Remember, we got this line to be minus x minus 1. So this equation here is negative x, negative 1, and I'm going to take negative x, negative 1, and I'm going to put it equal to my hyperbola. And that is my hyperbolous equation. They say determine the closest point to A. Closest point to A, and F that lies on F is going to be the point of intersection between the hyperbola and the axis of symmetry. Point of intersection, what do we always do? We put the two equations equal to each other and we solve for x and we solve for y. When I put this equal to each other, grade 11s, I can clearly see that I can solve for x. So I'm going to take my negative 2 over to this side. There's quite different ways that you can do, so you can see what you prefer. If the negative 2 comes across, it becomes plus 1, which is equal to negative 9 over x minus 1. I'm once again going to cross multiply, same as finding the LCD. So minus x plus 1 multiplied by x minus 1 is equal to negative 9. I am now going to just remove my brackets. That's negative x squared. That gives me negative x times negative 1 is plus x. This is another plus x here. Plus 1 times minus 1 is minus 1, which is equal to minus 9. All my brackets have been removed, and you can see that I'm going into a trinomial. Okay, so I have negative x squared plus 2x minus 1, bring that over, gives you plus 8, which is equal to 0. I'm going to multiply straight through by a negative because it makes my trinomial easier. And I have the following trinomial, which I'm going to factorize, x minus 4, x plus 2. And the x that you choose is going to be that x. Why can't it be negative 2? Because negative 2 lies where? In that quadrant there, in the second quadrant. But this question specifically stated that you want the point to be in the fourth quadrant. Good. So if it's in the fourth quadrant, x is equal to 4. If you want to get the y value, because they want the point, you can just substitute it into this equation, make x equal to 4, and your y is 5. The closest point between F and the closest point that lies on F in the fourth quadrant, it is going to be 4 and negative 5. Can everybody understand that? So hence or otherwise, determine the coordinates of a point that lies on F in the fourth quadrant, which is the closest to point A. The closest point to A is the point of intersection between F and the axis of symmetry. And we found that point to be 4 and negative 5. And grade 11, that point is indeed in the fourth quadrant. So you know that you did not make a mistake. We are moving on, and we are now on our last question with regards to this hyperbola. And I love this question because it's also a very popular question. It says the graph of F is reflected about the x-axis. Reflected about the x-axis. This is reflection about the x-axis. Do you agree? This is reflection about the x-axis. And now the question asks me, the graph of f is reflected about the x-axis to obtain the graph of g. Write down the equation of g in the form y equal to. Now remember, your original f of f's graph looked like this. Minus 9 over x minus 1 minus 2. If you reflect a graph over the x-axis, your value, your x stays exactly the same and your y changes to a negative. Your y changes sign. So I'm reflecting. I just did my reflection, but now I have to write it in the form y equal to, but you have a negative y. So you're going to multiply straight through by a negative. Grade 11s, when you reflect a graph over the x-axis, keep your x the same. Change your y to a negative and get y alone. Divide by a negative, so that negative becomes a positive. Remember, this is one fraction. Negative divided by a negative is a positive. So you can see that your graph is now not going to fall in quadrant 2 and 4, but definitely in quadrant 1 and in quadrant number 3 if you reflected over the x-axis. You can see, can you see? And it does that. And that is your equation. Now remember, you've written it in the form y equal to 9 over x minus 1 plus 2. Now some of you might be sitting there and asking, but ma'am, what happens if I reflect a graph over the y-axis? If I do this, remember, if you reflect a graph over the y-axis, your y will remain the same and your x changes sign. That is all that happens. Your y remains the same and your x changes sign. This question wanted me to reflect it over the x-axis, so my x remained the same and my y changed, and I just divided through by a negative. Grade 11, that concludes the question on hyperbolas. I'm feeling really good that we have the opportunity to even go into an exponential graph, and the exponential graph, there weren't quite as many questions on that, which will still allow me to even go to the parabola, and that was question number 6. Then we've done the number patterns. I've done a hyperbola with you. We're going to do an exponential graph and a parabola, which is quite good, and I hope that you're understanding and that I'm not going too fast. But remember, you can always just look at the production again. Okay, I'm going to put that away because there's no sketch for the exponential. They just gave us some information. If you are ready to work with me, it says, given that h of x is equal to 4 multiplied by 2 to the power of negative x plus 1. Grade 11, just quickly, which question am I on? These are the questions that were sent to you. This is the November 2015 paper, and it's question 5.2. We have now finished question number 4. We've done question 5.1, and we're on 5.2. I hope that you're all still with me. Okay, so it says that h of x is 4 multiplied by 2 to the power of negative x plus 1. How do I know that this is an exponential graph? Because it's to the power of x. Your x is a negative x, so this is going to be a decreasing exponential graph. If it was a positive x, it's an increasing exponential graph. But in one of these questions, they ask me to sketch it, and then I will explain decreasing and increasing to you. Question number 1 says, determine the coordinates of the y-intercept of h. This is now not a problem for us, not so, because if they're looking for the y-intercept, I make x naught. So I take my equation that is given to me, 4, open up my bracket, 2. I want the y-intercept, so I make x naught. Are you happy with that? Plus 1. Now you have anything to the power of 0 is 1. 4 times 1 is 4. 4 plus 1 gives me 5. So your y-intercept is 5. But we are going to lose 1 mark because they're asking for the coordinates of the y-intercepts of the y-intercept. So the coordinates would be x is 0, y is 5. And we've answered the first question again. Very, very simple. Now it says, explain why h does not have an x-intercept. Explain why h does not have an x-intercept. So what I did was, I took my equation. This is 2 to the power of negative x plus 1. And I actually went to go and test and look, okay, does it have a x-intercept? So how do I get my x-intercept now again, grade 11s? I make y equal to 0. This is 2 to the power of negative x plus 1. I'm going to carry my 1 across, which is minus 1. Now, how else can you write this? 2 to the power of negative x. 2 to the power of negative x can be written as a half to the power of x. It's the same thing. Do you agree? Here you can then take that over. You can divide by the 4 if you wanted to. Is that all right? So then it gives you, I'm just going to do that quickly. 2 to the power of negative x. I'm going to divide by the 4. This can be written as a half to the power of x if you wanted to. It's the same thing, or you can leave it like that. Now there is no way that this is ever negative. Does that make sense? A half to the power of x can never be a negative. So now you're going to say this is impossible. Do you understand? This half to the power of x is always positive. It can't be negative. Thus, there is no x-intercept. Is that quite good? If ever you have to answer a question like that, it would be very good for you just to go and see what, it will be very good for you to go and see why can't it have an x-intercept. Show you again, y is 0, carry the 1 across. The minute you divide it by the 4 here, you can even see you can never have a positive base equal to a negative base. They are half to the power of x. No matter what you substitute into the place of x can never ever be negative. There is no x-intercept. Question number 3. Remember I said that we're going to draw the sketch, and here's this question. Draw a sketch of h, clearly showing all the asymptotes, intercepts with the axis, and at least one other point. So come, I draw this with you. I sketched my y-axis, and I'm going to draw my x-axis. I'm going to sketch this graph. This is y, this is x, and this is the origin. And your graph equation is y equal to 4, 2 to the negative x plus 1. So the first thing, when I draw an exponential graph, I draw my asymptote. My asymptote here is a y asymptote, and it's just equal to 1. So I take it up, it's 1, and there is my asymptote. So that is your first mark, and you put your 1 down. So this is a y asymptote. Remember that an exponential graph doesn't have two asymptotes like an hyperbola. In hyperbola we had a x asymptote, it was the vertical asymptote, and we had the y asymptote, but not in an exponential graph. In an exponential graph, you only have your horizontal asymptote, which is your y asymptote, and it's equal to 1. Now I'm going to plot the y-intercept, grade 11s. Remember the y-intercept was 5, so I'm going to put 5 here, and now they want one other point. Now you can choose anything. I chose x to be equal to 1. So I substituted 1 into the place of x. 2 to the negative 1 there. I just substituted 1 in there just to see what I get. And this would give you 4 times a half, which is 2. 2 plus 1 is 3. So if x is 1, y will be equal to 3. That's the other point that I chose. You could have chosen anything else. You could even you could have chosen negative 1, any point, and there you have your exponential graph. Draw a sketch graph. We did it, clearly showing another point. And what did I say? This is a decreasing graph. An increasing exponential graph will look like that. It's a decreasing graph. Why? Because it's to the power of negative x. Very, very good, grade 11s. We are on to this last question. Describe the transformation from h to g if g of x is this. Now remember, g of x, if I multiply this out, I get 4 multiplied by 2 to the negative x plus 8. Now there are students who says that this times this gives them 8 to the power of negative x, but that's absolutely wrong. Remember that if you wanted to multiply this out, you can see that 4 is 2 to the power of 2. Can you see? Now your bases are the same and you can add your exponents. This is 2 minus x plus 8, but you don't need to do it. You can just go till there. So what is the transformation? Remember that you had h of x, which was equal to 4. Open up the bracket, 2 to the negative x plus 1. What do you have now? 4, still the same, but instead of plus 1, you have plus 8. So you shifted this graph 7 units up. You shifted it 7 units up, and that is the transformation that took place from here to there. And there we have answered question 5, which was the exponential graph. We've done exponential graph, we've done a hyperbola, and now we're into our parabola. Okay, so I'm going to bring this question here. The sketch is very, very clear, and I am just going to read to you quickly. I hope that I'll be able to answer these questions. Let's see how much time we have. So the sketch below represents the graphs of two parabolas f. Here's my f. Can you see? And g. So f is that one, and g goes there. No, the f is here. You can see arms up. It's f. I'm just going to make it clear. And here's my g. Are you okay with that, grade 11s? It says that the equation of f is a half of x squared minus 8. The turning point of g is 2 and 9. 2 and 9. I can see it. And the y-intercept of g is 0 and 5. b and d are the x-intercepts of f and g respectively. I've got all that information and I'm ready to go to my first question. My first question says that I need to show, I'm going to keep it here, I hope you can see the graph, that's all I want, I'm just going to push it, there we go. Show that g of x is negative x squared plus 4x plus 5, so I need to go and get the equation of g of x. I can see that my turning point is given, so I'm going to use the formula a open bracket, x minus p squared plus q. Why do I use this formula, grade 11s? Because they gave me the turning point. The p is the x-coordinate of the turning point. The x-coordinate of my turning point is 2. I take it directly from my sketch and I just substitute it into my equation. And q is the y-coordinate of your turning point, and it is 9. Now you want to find the value of a, so you sub in another point on your graph, and the only other point that I see is 0 and 5. So y is 5 and x is 0, helping you to find a. Are you quite happy about that? I'm going to work out a quickly. This is 5. This is 4, negative 2 to the power of 2 gives me 4. 4 times a is 4a. Carry the 9 across, it gives me negative 4, which means that a is equal to negative 1. Now remember, you have to get to that equation, and I'm going to quickly just substitute it in here. Minus 1, x minus 2 squared plus 9. Multiply this out quickly, grade 11s, and see if you get that. I just want to quickly, somebody says, ma'am, my question is, does the exponential graph have any lines? Let me just see. The axis of symmetry here. Remember, the axis of symmetry for an exponential graph is just your y value here. Okay, so I hope that you are okay with that. Remember, that is your axis of your asymptote, sorry, the plus 1 is your asymptote. It is plus 1. Someone says, ma'am, you're going a bit too fast. I know a little bit, I can feel it because I want to get through the parabola, and I say you can always go and work through this again. Remember that we're trying to get to minus x squared plus 5x plus 4x plus 5. I'm going to multiply out this bracket. It's x squared minus 4x. I hope you got this, grade 11. And I'm going to multiply in minus x squared plus 4x minus 4 plus 9 is plus 5. Oh my goodness, I got that equation. So that was the first question. Show that the equation of g of x is that. My next question asks me, calculate the average gradient of g between a and c. I so much want to get to this question because it's also so popular. If I see the word average gradient, you need to go and say average gradient is y2 minus y1 over x2 minus x1. Remember, that's your normal average gradient formula. So I want to find the average gradient between A and C. You're just going to substitute. I get 9 minus 5 over 2 minus 0. That gives me 4 over 2, and my average gradient is 2. Was that quite easy? Hey, not difficult. The average gradient there is equal to 2. Musa, I'm sorry that I'm rushing a little bit just so that we can get through the last few questions. And if there's anything that you battled with, please look at the DVD again so that you can just see, okay, this is what I didn't get. The next question tells me that I must determine the length from B to D. From B to D. So if I look at B, I can see that B is an x-intercept of f. So take your f equation, take the equation of f, which is a half a x squared minus 8, and get that point there. Can you see it's an x-intercept? So you make y naught. If I make y naught, I can solve for x. You can bring your 8 across here, or you can multiply by 2. So x squared will be 16. So what will x be? Plus or minus the square root of 16. So x can be plus or minus 4. So what is this point here? Minus 4. Now you want to get the coordinate of D. Can you see that D is also an x coordinate? So you are again going to get the equation of G, which we worked out. Remember, the equation was y equal to minus x squared plus 4x plus 5. I want to find the x-intercept, so I make y naught minus 4x plus 5. Multiply straight through by a negative, minus 4x minus 5. Factorize it now, x minus 5 plus 1. So what do you think? Your x is 5 or your x is minus 1? You choose the 5. Does that make sense? This point here obviously is going to be the minus 1, and this point here is going to be 4. Now what do you say is the distance from B to D? The distance from B to D is 9 units. Grade 11, I think that is all I have time for. There were 2 small questions still on these graphs on the parabola, but unfortunately I won't have time to do it. I do think that we got through quite a lot of questions. This to the students that felt that it was a little bit too fast, please go through these sums again. They are very, very good questions and extremely popular. The hyperbola, like we said, have 2 axes of symmetry. Symmetries, remember that they minus x plus c or x plus c. Substitute in your asymptotes there. And then for the exponential graph, we could get through the sketch. For the parabola, we use that formula where the turning point is given. Remember, y equal to a x minus p squared plus q. Okay, grade 11s, that concludes our session. Wish that I could do more sums with you. Good luck with your final preparation for your maths exam. It was really lovely being with you. Bye-bye.
Good afternoon and welcome to today's Accounting Telematics for Grade 11's broadcast. Today, Grade 11's, it's closer to the exams, so we need to take note carefully and work diligently with your teachers. So for today's afternoon session, what we'll be doing is we'll be going over creditors reconciliation as well as fixed assets. So in your telematics book, you need to look for activity number 2, and that deals with creditors reconciliation. Okay, so in your telematics book, if you look for activity number 2, you'll see there, it says creditors reconciliation. So before we tackle the creditors reconciliation, I just want to give you some useful tips on how to solve the creditors reconciliation problem. So if I look at the answer sheet, I just want to write some details very quickly. Right? Whenever you see the word invoice or interest, those words will be associated with adding. Okay, so you have to look for the word invoice and you have to look for the word interest, and it will be associated with an addition. Then also, if you're looking for the words the check, a discount, a debit note, or a credit note, that will be associated with a minus. So whenever we look at the transactions and using the word invoice or interest, then you know it was associated with adding. And in the same way, you look for the words check, a discount, a debit note, or a credit note. The debit note and the credit note, that deals with returns, and then you know it's associated with a minus. So this will be dealing with returns. Okay, so it's very important for you to understand whose books are we doing. Okay, you will always get two columns like you're seeing it in your answer book over there. The one column says creditors ledger of Drake Traders. That means we are Drake Traders. That's who we are, which means we will be doing the creditors ledger. Okay, so if I'm assuming this side was my debit, now I have a minus there and I'll add there, because creditors normally decrease on the debit and increase on the credit. One of our creditors are called Cupid wholesalers. So he is looking at us and he's saying, well, Drake, you owe me money, so you are my debtor. So the statement will work with plus and minus. Okay. Just once again, creditors, we see them as liabilities, so it's going to be minus on the debit, plus on the credit. He sees us as a debtor, so it's going to be plus on the debit and minus on the credit. Then just to recap quickly, whenever you see the word invoice or interest, you know it's associated with adding. When you see the word the check, the discount, the debit or the credit note, then you know it's associated with and minus. Okay? So all we have to do, we have to go through the transactions, we have to plus or minus in either column, and then hopefully at the end, these two totals here should be equal. And if it's not equal, then we'll look for the difference, and then we'll go and solve wherever we might have made a mistake. But hopefully we won't be making any mistakes, and then we will take it through. Okay? So what we've got to do now, we will go through transaction by transaction, and then we have to fill it in the table that we had earlier, and then we should be able to get it done. Okay, so we look at the first one. They're just telling us that we have to use the table in the answer book to indicate the difference that were discovered when comparing the account in the creditors ledger with the statement received from Cupid wholesalers. We only have to write the amount in the appropriate column, and then we have to make a plus or a minus to indicate if it's an increase or a decrease. And then at the end we have to calculate the correct total or the balances, which means the two figures at the bottom should correspond. Okay, right, so then it says the first transaction. It says the check. So now immediately the light should go on. It says a check, which means it's associated with a minus. Okay, the check, it's associated with a minus, as well as the discount. Now it's saying The check in settlement of the May account was not received by Cupid wholesalers within 7 days, which means they have received it, but it wasn't within 7 days. The discount of 1,500 recorded by Drake in the creditors ledger must be cancelled. So we must not record the discount, we have to go and cancel the discount that was recorded earlier. Now it says that the discount that was recorded in the creditors ledger must be cancelled, which means in the creditors ledger, when we recorded the original discount, we went to go and minus the discount. This is our creditors ledger. So in the creditors ledger, when we recorded the original discount, we went to go and minus that discount. But now it says that we have to go and cancel that discount. So the only way to go and cancel a minus is to go and add 1,500. Okay. So why do we do this? Because earlier we deducted the discount from the account, but we weren't eligible to get the discount because we didn't pay within 7 days. So now we have to add back the discount. Okay. That means there will be no entry on the statement because the statement won't indicate any discount. Okay. The reason why the statement is not indicating the discount, they never received the payment within 7 days. Okay. So all you have to do over there, it will be add 1,500 in the ledger, and that is only to cancel the discount that we had taken earlier. Okay, right, grade 11. Then we look at the second transaction. It says a check for 9,000. So immediately I just gonna have a look on top. Okay, so it says a check, a discount, a debit or credit note is associated with a minus. Right, so it says a check for 9,000 issued by Drake had not been recorded on the statement. Okay, so there's the answer sheet. This is the ledger. It says we gave them a check. It was recorded in the creditors ledger, but it does not appear on the statement. So that means on the statement, because it's a check, it's associated with a minus. You just have to minus the amount of 9,000. Okay. Right, so then the third transaction, it says an invoice of 4,500. It says an invoice for 4,500 received from Cupid. Right? So in other words, it's an invoice, so it's going to be associated with an plus or an addition. Third transaction says an invoice for 4,500 received from Cupid was incorrectly recorded as a credit note by Drake. So in other words, it's an invoice that was recorded as a credit note, or it is a plus that was recorded as a minus. Okay, and the mistake is only by Drake, and that is who we are. Okay, so whenever you get a transaction like this, you first have to identify who has made the mistake. So the mistake was made by Drake, which is us. Now it says it's an invoice, so you were supposed to go and add, but you went to go and minus. Okay, so you have to add 4,500. That's to fix the mistake. Then you have to add another 4,500 to do the correct thing that you're supposed to have done in the first place. So we could have just said we just have to double the amount and then add 9,000. Okay, so let's just look for that one again quickly. It says an invoice, which is associated with a plus, was incorrectly recorded as a credit note, which is associated with a minus. So in other words, we went to go and minus instead of adding. So now we have to double add, okay, which means add 9,000, or first add 4,500 to cancel the mistake, and add 4,500 to do the original thing. So there won't be any entry there in the statement, and obviously there won't be any entry over there in the ledger for transaction number 2. If we look at transaction number 4, it says returns. Right? So whenever we are returning something, it's either the debit note or the credit note that was in use, and it's associated with a minus. Okay. So in returns, it says returns recorded as 2,700 in the creditors ledger was recorded as 3,000 in the statement. Okay, so it's 2,700 in the ledger and 3,000 in the statement. Then it says Drake traders, which means creditors ledger. Drake traders has miscalculated the cost of the goods returned. In other words, what happened was we minused 2,700 earlier, and on the statement it shows a minus of 3,000. Right? So for now the statement is correct, so there's no entry on the statement. We minus 2,700 instead of minusing 3,000. So now you only have to minus the difference, which will be 300. Okay, so that will be the difference of, that's the difference of 3,000 and 2,700. So you only have to minus 300 over there. Okay. Then transaction number 5. It says an invoice received. So again, the invoice that's associated with adding was correctly recorded as 9,900 by Drake, which means in your ledger that was recorded as 9,900, which means that is correct. But on the statement the figure shows only 990. So the first thing that we have to do, the statement has added too little. So now you have to add the difference between 990. So the difference between 9,900 and 990 is 8,910. So we only have to add 8,910. Okay. Then hopefully grade 11. So what we have to do now, we have to take the opening total minus the 9,000 plus the 8,100, and then the opening total plus the 1,500 plus the 9,000 minus the 300, and get a total, and hopefully these two totals at the bottom will be the same. Just check if there's any information coming through. Okay, nothing. Okay, so we go to our calculator quickly. Right, so it's 23,730 plus 1,500 plus 9,000 minus 300. That gives us a total of 33,930. Okay, so hopefully when we plus and minus the figures in the statement column, we should get the same figure. So it's 34,020 minus 9,000 plus 8,910. And that also gives us a figure of 33,930. Okay. There you can see that the total according to or the balance in the ledger and the balance on the statement now agrees, and hopefully all the entries will be correct. Okay. Just to recap on that quickly, which is going to make our life a little bit easier. Whenever you see the words invoice or interest, then you must know it's associated with adding. a check, the discount allowed or the discount received, a debit note or credit note, which is associated with returns, will always indicate a minus. Okay? Then all we have to do, we just have to find out which one is correct, and then we just have to fix the mistake in the one that has made the error. Okay? Hopefully grade 11, that is just a small revision section of the creditors recon that you were doing during the year. Right? So what you've got to make sure, you've got to make sure that you understand the transactions carefully, right? And you know how to fix them when we're doing it on the table over there. Okay? So that shouldn't be so difficult when it's in the upcoming exams, as long as you make sure you understand what you're doing. Just remember, for some useful tips, the invoice and the interest is associated with adding. The checks, the discount, the debit note and the credit note is associated with subtracting. Okay, that will be the easy part. So that will be the creditors reconciliation for this afternoon session. Okay, the second part that we have to deal with now, it's all about fixed assets. Okay, so that will be activity number 3 in your answer book. Okay, so it's going to be activity number 3 in your answer book, which would be all about just the question on fixed assets. Okay, so we've got the fixed assets over there. Then they're asking questions, which is very popular in grade 11 as well as in grade 12. Okay, which is extremely important for you to make sure that you understand the fixed assets, the way it operates and the way it works completely and thoroughly. Not to forget that you need to understand how the ledger accounts works as well as the fixed asset note that we'll be doing this afternoon. Okay, and hopefully this information you'll be carrying over to your matric year, which is next year. Okay. Right, so what do they give us, or what do they want from us? First of all, they are talking about a fixed asset register, which we just call the FAR, which is just your fixed asset register, right? Which is the F, the A, and the R. Okay, so it's asking what is a fixed asset register. Then also the second part of that question is why is it important that the business keeps a fixed asset register. Okay, so the first thing, what is a fixed asset register? Okay, we can say it's a book that contains all the details of all the fixed assets owned by the business. Okay. So what we're saying, that the fixed asset register is a note that contains all the details of all the fixed assets owned by the business. Okay, which means any fixed assets, land and buildings, vehicles and equipment that the business owns, there will be a detailed description of it in the fixed asset register. The fixed asset register will contain the cost price, for example. It will also have the accumulated depreciation. It will have the date that we purchased it. And if we are selling it, it will have the date when the item was sold, and we no longer have the item physically. Okay? So that's why we're saying that it contains all the details of all the fixed assets that is owned by the business. Amongst others, it will contain the cost price as well as the accumulated depreciation of all the fixed assets owned. We just have to remember that land and buildings does not have any accumulated depreciation. Okay. Then the second part of that question asks us, why is it important that the business keeps a fixed asset register? Okay. We need to keep a fixed asset register so that we can have accurate records of all the fixed assets owned. Right? we need to keep accurate records for all the fixed assets owned by the business. Okay. What else? The physical existence. Right? The physical existence can be verified by the description. Okay. So for one, we need to keep accurate records of all the fixed assets that is owned by the business. The second reason, it's also that the physical existence of the fixed assets can be verified by the description in the fixed asset register. Right? So these are two of the reasons why keeping a fixed asset register is important for a business. Just have to remember, the fixed asset register is a book that contains all the details of all the fixed assets owned by the business. Amongst others, it contains the cost price and it contains the accumulated depreciation. Right? Why is it important? For accurate records to be kept and to verify the physical existence. Okay, that's a bit of theory regarding the fixed asset register. Then the other part of the question, it says that we have to calculate the depreciation on equipment for the year. Okay, it says calculate the depreciation for equipment. But I'm just looking at the question quickly. The question is giving us land and buildings, and the question is giving us equipment. And I see in the information, the section by B, they only have land and buildings, and then by C, they have equipment. So maybe just for the sake of simplicity, let's first tackle the land and buildings, and then we just concentrate on your equipment, right? So let's just concentrate on the land and buildings quickly, and then we concentrate on the equipment. Okay, so it says for land and buildings, they are giving us a total at the end of the year, where it says the cost price of the land and buildings at the end of the year. The cost price of the land and buildings is 1,230,000 at the end of the year. Right? And the equipment is 615,000. But let's just discard the equipment. Let's just deal with the land and buildings first. Then in the information section by B, it says on the 31st of August 2015, 120,000 was paid to quality builders for the following: a new office of 93,000, which means we renovated and we built on a new office to the value of 93,000. Then also it says that repairs was done to the stores for 27,000. So the 93,000 and the 27,000, that in total gives me 120,000 that they're talking about in the first sentence. Then it says the full amount had been debited. In other words, the whole amount, the whole 120,000 has been debited to land and buildings. Now that part there where it says the whole amount, that is where the business made a mistake. Okay? Because only the 93,000 had to go to land and buildings and not the repairs. So what they did, they added 120,000, so the total became 1,230,000. So what we can do, we can take the 1,230,000 and take away the whole 120,000. Then we're sitting with 1,110,000. Okay. So what I did, I took the 1,230,000 and I took away the 120,000. So I'm ending up with 1,110,000. So what is the 1,110,000? If the 1,230,000 is the cost price at the end, and I'm taking away whatever was added on, then the 1,110,000 is clearly the cost price of the land and buildings at the beginning of the year. So when I look at my note, at my fixed asset note for land and buildings, where it says cost price, these three lines are at the beginning of the year, and these three lines over here at the bottom for the fixed asset note is at the end of the year. So now I have a figure of land and buildings at the beginning of the year, 1,110,000. I have that figure. Okay. Earlier I said there's no accumulated depreciation. So the cost price minus the accumulated will give me the carrying value, which is also 1,110,000. Right. When it comes to the movements, we have additions, disposal, and depreciation. So there won't be any depreciation. In the exercise, we also didn't get rid of any land and buildings. But what we did was, we bought, or we had a renovation made to the value of 120,000, but only 93,000 was allocated for the land and buildings. The other 27,000 was repairs, but by mistake the bookkeeper took the whole total to land and buildings, which means the bookkeeper only had to take the 93,000 to the additions for land and buildings. So that part over there, it's only 93,000. Okay. So now all we have to do now, we have to get the value of the land and buildings at the end. So it's 1,110,000 plus 93,000. And that gives me 1,203,000. Okay. Now accumulated, so the cost price at the end is also 1,203,000. Okay. What we could have done also, grade 11, let's just take the 1,230,000 and we minus the 27,000 and we're getting the 1,203,000, and then we have to work back to get to the, so you take the 1,203,000 minus the 93, and then we get the total of 1,110,000. Okay. Remember, if you're working in the opposite direction, then you have to do the opposite, because additions obviously means that you have to add, and the disposal it's minus, and the depreciation will also be minus. Okay. Because we're working in the opposite, we have to do the opposite. Okay. That takes care of the land and buildings part. So now all we have to do now we have to calculate the depreciation, and we have to do the equipment part of the fixed asset note, and then we just have to answer the question. Okay. So what it says is we have to calculate the depreciation on the equipment for the year. But as you can see in your information, there's an amount given of 180,000 for accumulated at the beginning of the year. So accumulated at the beginning of the year is 180,000. They're not mentioning anything what is the cost price of the equipment at the beginning of the year, so it looks like that is the figure that we'll have to go and calculate. But what they also give us in the information is it says at the end of the year the cost price is 615,000. Okay, 615,000 at the end of the year, and the accumulated at the beginning of the year is 180,000. Okay, so what the information giving us is they want us to calculate the depreciation on the equipment for the year. Okay. So it looks like we're going to have depreciation on the item that was sold. We're going to have the item that was sold, then we're going to have depreciation on the item that's remaining, and then we'll have depreciation on the item that is new. So we just have to look at the information quickly. It says under equipment, it says on the 1st of December, obsolete equipment was traded in. So as soon as you see the word trade in, that part, as soon as you see the word trade in, then you should know creditors control will be involved in the transactions. Okay, because we're trading it in, and we're trading it in probably on buying something new as well. So besides the trade in, it's obviously buying something new. Then it says the cost price of the equipment that was traded in now. So the cost price was 60,000. And the accumulated depreciation on that equipment on the first was 42,000. Right? That's your accumulated. So we minus. Why do we minus? Because we want to calculate the depreciation according to the diminishing balance. So that gives me 18,000. Right, so I've got 18,000 and I multiply it with 20%. Now it's important to find out when was this equipment sold. Right? Now it says on the 1st of December. But your financial year starts the 1st of March. So you have to look at the dates from the 1st of March until the 1st of December. And that gives you 9 months, which means that equipment aged for 9 months before you sold it. So it's going to be 18,000 times 20% times 9 over 12, and that gives you 2,700. Okay. So the depreciation on the item that was sold, right? The depreciation on the item that was sold is 2,700. So now we have to look at, did we buy anything? Now, because the vehicle was traded, the equipment was traded in, we clearly had new equipment as well. Okay. So what does it say? It says that the trade-in offer of 22,000 rand was accepted, which means we gave in the equipment, and the creditor gave us 22,000 rand for that equipment. The equipment was fairly old, so obviously we accepted 22,000 as the value for that equipment. Not necessarily the book value, but that is what the creditor has given us. Right? Then it says also that on the cost price of the new equipment, which means we bought new equipment. Right? So now, because we bought new equipment on the same day, we also have to write off depreciation on the new equipment. And the new equipment is 90,000. So in your fixed asset note, it clearly says that we bought new equipment to the value of 90,000. Right? So under the additions, we bought equipment for 90,000. But what was the depreciation on that new equipment? Now, because it's new, there is no accumulated that belongs to the new equipment. So because the equipment is new, there's no accumulated, you have to write off the depreciation on the cost price. So it's just, the cost price is 90,000 times 20%. You bought it the 1st of December because that's the day that you traded in the old equipment for the new equipment. So you only have it from the 1st of December until the 28th or the 29th of February 2016. Right, so that will only be for 3 months. So you have to write off depreciation for 3 months on the new equipment. So it's going to be 90,000 times 20% times 3 over 12. So it's going to be 90,000 times 20% times 3 divided by 12. And that gives me 4,500. Okay. So the depreciation on the old equipment was 2,700. Sorry, on the equipment that was sold was 2,700. The depreciation on the new equipment was 4,500. So over here I have to add 4,500 as depreciation on the new. Just make a note. That's the depreciation on the one that is sold. That's the depreciation on the new. Okay. then there should still be depreciation on the old. In other words, on the old equipment that we had besides the 60,000 that we had at the beginning of the year. Okay, so what do we see over here? We have a problem because we are struggling to calculate what is the cost price of the equipment at the beginning of the year. But once we have all the information, then hopefully we should be able to get it. So what it's saying is, I had equipment with a cost price at the beginning of the year, which I don't know. I want to calculate, so I make the unknown any letter, but because we're doing maths, so we normally just take x. Then we added 90,000. That was the cost price of the new equipment that we bought. And we minus 60,000. That was the cost price of the item that was sold. So we ended with 615,000. Okay. So now what we're going to do, we're going to move everything over and change the sign. We're going to move everything over and change the sign. Then we're going to end up with 615,000 plus 60 minus 90. And that will give me 585,000 at the beginning of the year. Okay, so now I have the equipment at the beginning of the year. Then automatically, because I have the cost price at the beginning of the year, I can go and calculate what is the carrying value at the beginning of the year, which is just 585 minus 180, which gives me 405. Right. Now what? Now I know automatically that in the equipment at the beginning of the year, I must take away a 60,000, because that is the 60 that we have that we sold. And in the accumulated at the beginning of the year, I have to take away a 42,000, because the 42,000 accumulated belongs to the 60 that we sold. So what I want to calculate, grade 11, is how much depreciation do I have to write off on the old equipment that is remaining. So the cost price of the old equipment, is going to be 585 minus 60, which gives me 525. And the accumulated of the old equipment is 180 minus 42, and that gives me 138. Now I can calculate what's the carrying value of the old equipment, and then I can calculate what is the depreciation on the old equipment. So it will be 525,000 minus 138,000. That gives me 387,000. And I multiply that with 20%. It gives me 77,400. Right. So the depreciation on the old is 77,400. Okay. So let's just recap that one, because it can become cumbersome. We have the cost price of the equipment at the end of the year. Right, so we're looking for what is the cost price at the beginning of the year. So we made, right, the cost price at the beginning of the year is X, which we don't know. We added the 90,000 of the new equipment that we bought, and we minus the cost price of the old equipment that we sold. And then we got the figure of 615, the cost price at the end. Okay. When we do the equation, we find out that the cost price at the beginning of the year is 585,000. So we slot in the 585,000 at the beginning, minus whatever we sold, so we got 525 left. Right, the accumulated, there was 42, so 180 minus 42 gives me 138,000. I come to 387,000, I multiply that with 20%, I get 44,000. So now the total depreciation is going to be 77,400 plus the 2,700 plus the 4,500. And that gives me a total of 84,600. I need to keep that in brackets because that will decrease my carrying value at the end. Okay. So the total depreciation, so in the block on top, that's the depreciation on the sold, that's the depreciation on the new, and the 77,400. So altogether, it gives me 84,600. That's the depreciation altogether. Right? So that's the sold, that's the old, and that is the new. Okay, so we still need to fill in what is the disposal, that value, but that will go in brackets. Okay. Now the line says the disposal at carrying value. So the line, so disposal at carrying value means take the cost price minus the accumulated depreciation. Now the cost price of the equipment that we sold was 60,000. Remember we took the 60,000 out over there, and the accumulated at the beginning of the year was 42,000. But you're not going to minus the 42,000 because the equipment became 9 months older. You went to go and write off an extra 2,700. That equipment became 9 months older, so you went to go and write off an extra 2,700, which is the item over here that we have on the depreciation for the item sold. So that 2,700 needs to be added to the accumulated at the beginning of the year of the 42,000. Then in total it's going to be 44,700. Right, so then I say 60,000 minus 44,000 gives me 15,300. Right, so then we have to do some calculator work. Right. Now there's two ways of doing it. You can start with the 405. That means I'm looking for carrying value. So it's 405,000 plus the 90,000 minus 15,300 and minus 84,600. That gives you 395,100. Okay. Then all we have to do now, we have to calculate the figure which is the accumulated at the end. Okay. Which means to get the accumulated at the end, you just take the 615,000 minus 395,100, and we get 219,900. Okay, that's the one way. Or what we could have done was you take the 180,000, in other words the accumulated at the beginning of the year, you take the 180,000, you add all the depreciation of 84,600, and you minus all the accumulated of the item that was sold, which was 44,700, and then we should get the same answer of 219,900. So let's just check if that will give us the same total. It's 180,000 plus 84,600 minus 44,700. And that gives us 219,900, which is the same as that total over there. Right, grade 11th, your fixed asset note, especially when there is asset disposal involved, that is the one that becomes a bit more difficult or cumbersome. So you need to make sure that you understand when do you add and when do you subtract the accumulated of those items involved, especially if there is asset disposal involved. Okay? So what you're going to make sure is that in this one that we had to calculate what was the cost price at the beginning of the year. So unfortunately over here we had to go back to a basic equation to solve for x so that we can find what is the cost price at the beginning of the year. Then we had to split it between the item that was sold, which was 60,000, and the item that was remaining was 525,000. So that was the item that was sold, and this one is the old, that was the old one that was remaining. Okay, so now we'll just move on to the question quickly, because it says that we also have to prepare a asset disposal account. Okay, which we should get. But it says that we have to prepare a asset disposal account. Just one mistake there, printing error. It was not sold at the end of February, but it was sold at the beginning of December. Okay, so it was sold at the beginning of December. So the main idea of you drawing up the asset disposal account is to make sure that you determine what is the profit or the loss on sale of asset. Now most of this information you can find in your fixed asset note. All this information that we have over here you can find in your fixed asset note. But especially on the debit side, for example, we're going to have the cost price of the item that was sold, be it vehicles or equipment. So in this case it was equipment, so we're going to find the cost price of equipment that was sold. So we have to write there the contra account is equipment. And we know, grade 11, that from the question it says equipment with a cost price of 60,000. So that cost price was 60,000. Right? Equipment with a cost price of 60,000. Then the item on the credit side is going to be accumulated depreciation on equipment. Okay. Now remember, the information says that the accumulated at the beginning of the year was 42,000. It was at the beginning of the year 42,000, but we wrote off an extra 2,700. So we got to a total of 44,700. So the accumulated, that was at the beginning of the year, which was the 1st of March. But this was the accumulated on the day that we sold it, which is the 1st of December. So the 44,700 goes in over there. And that will be the figure that we had at the beginning of the year, plus the extra depreciation that we had to write off, which you'll find in the depreciation sold. In other words, it was 60,000 was the cost price. Then you can see the 60,000 appears on the debit side. The 44,000 was the amount of accumulated that we had at the beginning of the year. We wrote off an extra 2,700, so now we have to update the accumulated. That's why we say 42,000 plus 2,700 gives me 44,700. But then in the information it says that we traded the vehicle in for 22,000. Now as soon as we trade in, we said that the contra account will have to be creditors control. So it's only creditors control when there's a trade in. Obviously, if we sold it for cash, then the control would have been bank. Or if we sold it on credit, then the control would have been debtors control. Okay? Then you can see the only thing that we have to calculate now is to determine whether it's a profit on sale of asset or a loss on sale of asset. The debit side gives me 60. So, and this gives me 66,700. So the total should be 66,700. So the balancing figure should be 6,700 on the debit side. Right, so what do we call that? That's what we're talking about. But let's just look at this item here quickly. There's a line in the fixed asset note that says disposal, which refers to the asset disposal account, at carrying value. Carrying value is cost price minus accumulated. So if I look at the asset disposal account, I have the cost price of 60,000 minus my accumulated depreciation of 44,700, and I get an answer of 15,300. Right, so that's the cost price, that's the accumulated depreciation, and that will be the book value, or also called carrying value. So the item is worth 15,300, and I traded it in for 22,000. I traded in for more than what it's worth. So the 6,700 will be called a profit on sale of asset. So it's profit on sale of asset. Okay, here you go. That will eventually end up in our income statement, right? And the 15,300 ended up in the fixed asset note. Right. Let's just move on to the last part of the question, where it says the owner is concerned about the internal control over fixed assets of the business. Suggests 3 internal measures that could be implemented. Right. So whenever we have fixed assets, the first item is to make sure that we safeguard the fixed assets against theft or loss. So safeguard against theft or loss. Right. If any of the fixed assets is damaged, so damaged or stolen, damaged or stolen items must be reported immediately. Right, in the third internal control measure, that we must make sure that there is proper authorization, procedures in place. Okay. In other words, we must make sure that the people are properly authorized to use the fixed assets. For example, if we're having a car and we have to take the vehicle or the company vehicle home, then there should be proper authorization procedures in place. Right? Then we can also have verifications to the fixed asset register. Right? So we have verifications, or the verifications to the fixed asset register on the physical existence. Which ties up with the first item that we have. But the most important one, whenever we have fixed assets grade 11, we make sure that we have to safeguard the fixed assets against theft or loss. Damaged and stolen items must be reported immediately. Proper authorization procedures are in place for the private usage, and verification to the fixed asset register to ensure that the fixed asset actually exists. That's why we have to determine the physical existence to the description that appears in the fixed asset register. But grade 11, once again, the fixed asset component, the asset disposal, and your fixed asset notes are very important for you to understand. You've got to make sure that you understand it properly, not to forget to take the internal controls into place. Then make sure that you master this section carefully and take them over to grade 12. I wish you everything of the best for your upcoming grade 11 exams, and hope to see you next year in grade 12. Everything of the best, and thank you very much. Goodbye.